What's up, guys? Looking at reacting masses this video. Make sure you've watched the video on MR formula mass first, otherwise there are going to be gaps in your knowledge. So this is super important. Triangle here. Mass, Mr. Mole. I think that's quite rhythmic. It's quite easy to remember, right? Mass, Mr. Mole, mass, Mr. Mole. And so we sort of cover it up. If we're working out what mole is, we're doing mass divided by mole. If we're working out what mass is, we're doing MR times mole. We know how to use these triangles, right? Mass, Mr. Mole. And at the start of questions, I'm even going to quickly jot down mass, Mr. Mole, just so I know what I'm working with, I know what I'm doing. Now, mass is always going to be in grams here. Moles, actually we'll do this first. MR is grams per mole, and moles is just that, mole. Okay, now that means that if we get anything other than grams, we're going to have to do a unit conversion. You get the drill, right? Again, make sure you've watched the video on MR so you know what we're doing here. So, easiest way to go through this is to do some practice questions. That's exactly what we'll do. 16 grams of oxygen reacts with methane. How much carbon dioxide is produced? So, generally speaking, to be honest, you're going to be given the equation, but you also need to be able to work out what these equations are, right? So this is a combustion reaction. Methane, meth meaning one, ane saturated, so we've got CH4 plus oxygen is O2, it's diatomic, makes combustion, we're always going to have CO2 plus H2O. Let's not worry about state symbols for now. And we balance that. We're going to need 2 of the H2O, otherwise we're odds. We need 2 O2 as well. So the first challenge here comes from decoding the question. So 16 grams of oxygen. What I like to do is to just tick off the thing that I've got the information for. And it might be that I tick off 2. In this case, I'm only ticking off 1. Reacts with methane. Now, the mistake lots of people make is they jump straight into it and they think, okay, I've got to work out something to do with methane. That's not the case. How much carbon dioxide is produced? And I like to put a little question mark above the thing that I'm trying to work out. So, first step, decode. Second step, I like to present my information in a table. And the reason why is that examiners often talk about the difference between lower ability students and higher ability students. And the higher ability students are able to organise their information better, which means it's easier for examiners to find out where people have lost marks, gained marks, etc. So wherever possible, I like to present the information in a table. So we've got 2O2 and we've got CO2. These are the things that are important. And here I've got mass, Mr. Mole. Okay, and I might just do this. Perfect. So step 1 is I need to take the information from the question and from the periodic table and put things in the right place. So 16 grams of oxygen, I need to fill that in. 16 grams. MR, I need to work out, right? So I go to my periodic table. Oxygen is 16, carbon is 12. So I've not got to do too much there. So oxygen, again, make sure you've watched the previous video on MR. We ignore the big numbers when we're working out the MR. We worry about them later on. So we've got 2 lots of 16, which is 32. Okay, for carbon dioxide, I've got 1 lot of 12 and I've got 2 lots of 16. So that takes me to 44. Now, I've got 2 pieces of information for this. So mass, Mr. Mole. Here, I need to do mass over MR. So that's my 16 divided by 32. and there I get to 0.5. Now, this is where I do need to pay attention to those big numbers. 2 moles of O2 makes 1 mole of CO2. So to go from 2 to 1, I need to divide by 2. And that's exactly what I'm going to do here. I'm going to divide this number by 2. And I get to 0.25. Okay, this is a step where lots of people will make mistakes. If you have made a little mistake here and there, presenting our information this way is going to make it easy for the marker to spot what's going on. And our final step, we're working out our mass. So cover up our mass, we've got MR times mole. So that's our 44 multiplied by 0.25, and we get to 11 grams. Circular answer, happy days. On to the next one. So, how much aluminium is produced when it is extracted from 2,080 grams of aluminium oxide? Again, bigger numbers, not scary. We just deal with them in exactly the same way. So, first step, again, you're probably going to be given the equation, but why not give it a go like this first of all? So, aluminium oxide. Aluminium is in group 3, so it's got a 3 plus charge. Oxygen's in group 6, so it's got a 2 plus charge. So it's going to be Al2O3 to balance that out. I'll do a video on ionic formula a little further down the line. And it's just an extraction. So we've got 2Al plus, well, it'd be 1.5 O2, but that's no good, is it? Not for our purposes now. So we've got 2, we've got 4, and we've got 3 lots of O2. Okay, now let's decode this. We've got the information for aluminium oxide, 2080, and we're being asked about aluminium, right? So let's put that in our table. We've got 2 lots of Al2O3. We've got 4 lots of Al, and then we've got to think about mass, Mr. Mole. Our mass for aluminium oxide was 2080. MR, if we go to our periodic table, things we need to worry about, aluminium is 27, oxygen is 16. So I've got, again, ignore the big numbers, only look at the little numbers. I've got 2 lots of 27 plus 3 lots of 16. And there I get to 102. And for Al, we've obviously just got 27, 1 lot of 27. Again, quickly jot our mass, Mr. Mole. So I need to do mass divided by MR. And there I get to 20.39. A little, it's obviously longer than that in the calculator. What I suggest you use a lot of the time when you're doing this is, if I come to here, is use answer as often as possible. Every time you press equals, you're losing significance. So do your calculation, and then when you're coming on to the next part, do times answer or divide by answer. Okay, carry that forward. So when I put ... here, I'm using what's said in the calculator to work out what's going on. Now, 2 to 4, I've got to times by 2. So here, I'm going to times my moles by 2. And there I get to 40.78, ... Again, I'm going to use answer in my calculator because now I'm going to do mass equals MR times mole. 27 times answer gets us to 1,101.18 grams. Circle your answer, And then got a past paper question for you to give a go. Okay, so this is looking at this stuff. It's giving you the values here. Screenshot this, give it a go. Let's move on to the answers for the last bit. Again, 3 moles of H2. All I need to do is multiply that by Avogadro's constant, my 6.022 times 10 to the 23, and I get to 1.8066 times 10 to the 24. Here, 1022 molecules of H2. There, I just need to divide by my Avogadro's constant, 6.022 times 10 to the 23. And there I get to 1.697 times 10 to the minus 21. And finally, Na plus ions in 2 moles of Na2CO4. So there, remember, we're going to get 2 lots of Na plus produced. So I've got to multiply this 2 by 2. So I'm going to do 4 times Avogadro's constants. So I get to 2.4088 times 10 to the 24. Thank you very much. Happy revising.